Okay, 8.3, the graphs of sinusoidal functions. Okay, so here is a sinusoidal function. It is any periodic function whose graph has the same shape as that of y equals sine x. So this is so you can see it goes up and down, repeats a pattern. Determine the range of this graph. So the lowest this graph goes is -4 to the maximum height of 2. Okay, determine the range. So keeps going and going, keeps going and going. Or we could write these as x is any real number, or we could write this as y is less than or equal to 2 and greater than or equal to -4. Determine the period. So how long does it take to complete a cycle? So let's say that the cycle starts there. So you can see that at this point in time we are back and repeating again. So it took pi to complete a cycle. And determine the midline. So you can see that halfway between a -4 and a 2 is -1. So y equals -1. The amplitude is how far you are stretched off of the midline. So we go 3 up and 3 down from the midline. So that amplitude is 3. Determine the equation of this sinusoidal function. Okay, so we are going to go to our calculator and we're going to type in some coordinates. Okay, so this is 0, -4. This one would be pi over 4, comma, -1. Pi over 2, comma, 2. This one would be 3 pi over 4, comma, -1. And then this would be pi -4. So first thing is I want to make sure that I go to my mode and then make sure that I'm in radians, not degrees. Okay, I'm going to stat edit. I'm going to go 0, pi over 4, pi over 2, 3 pi over 4, and pi. And then I'm going to give my y coordinates, -4, -1, 2, -1, -4. So those are my coordinates. And I'm going to turn my stat plot on. And I'm going to go zoom and go down to zoom stat, zoom 9. So you can see those. Oh, I must have something in my y equals. I'm going to get that out of there. So you can see that. Okay, now stat calculate. And you're going to go down to find a sine regression, very bottom. Okay, and let's see what comes up. There we go. So there's our equation. Y equals 3 sine 2x minus 1.75 minus 1. Okay, and remember you can graph that if you want. You would go to y equals and then vars statistics and then go over to equation, regular equation, and it puts that in for you. And let's see if we graph it, does it connect through those points? Yes, it does. Okay, next question. A Ferris wheel that is 60 feet in diameter makes a revolution every 80 seconds. If the center of the wheel is 35 feet above the ground, how long does it take a rider to start? Okay, let's just draw this out. So the middle is 35, and if the diameter is 60, it means you go and go 30 up. So the highest you reach is 65, and then the lowest would be 5. Okay, so at time 0, you're at 5 feet. So there's your start. And let's talk about the time. It takes 80 seconds to go around. So this would be 40 seconds. This would be 20 seconds, 60 seconds, back to 80 seconds. So let's make some coordinates. So 0, 5, 20, 35, 40, 65, 60, 35, 80, you're back to 5. Okay? So we're going to go put those into our stat edit. Up, clear down, up, clear down. So 0, 20, 40, 60, 80. And then match up 5, 35, 65, 35, and 5. Okay, I'm going to actually erase my y equals because I still had that. My plot one is on. So I'm going to zoom stat, zoom number 9. And there is the Ferris wheel. Okay, so I'm going to go stat, calculate, and the bottom, sine regression. And there's my answer. Okay, so y equals 30 sine of 0.08 x minus 1.57 plus 35. And those numbers do keep going. Okay, so I want that into my y equals, so I'm going to go y equals vars stat equation, regular equation, and then it puts it in there for me, so I don't have any rounding. I'm going to graph it, and you can see how it connects to the curves, or to the points. So that matches. Now I'm actually just going to go back to my stat and turn that off, because I don't want those points on there anymore. I just want the curve. Okay, so we're asked to see where is it going to be a height of 50. So I'm actually going to go into y equals and go to y2 and type 50 in there at a height of 50. So you can see you're reaching a height of 50 right here and right here. So how long does it take? So I'm going to calculate that intersection. I'm just moving my mouse a little closer to that intersection. Enter, it jumps, enter, and then enter a third time. And at 26.66 seconds, you will reach that height. So somewhere right here, right? Then you go up, and then you'll also be descending, and you'll reach 50 feet again over here. So we could find this one as well. So I'm just going to move my mouse closer to that intersection. See my mouse moving, enter, it jumps, enter, and enter a third time, and 53.33. So that's when you reach 50 feet.